Welcome back, everyone. So we have ready for you Dennis de Bode, Sajid, Mohideen, and Nick Tinnemeier with the presentation. Don't tell my manager, I generate my code. Questions for this presentation can be put into Mentimeter. Check the Q&A on this team chat for the code. We will have a live Q&A at the end of this presentation. Nick, Dennis, Sajid, are you with me in the call?
Yes,
we are.
All right, great. So it's over. It's up to you guys. It's over me. Let's call it like that. It's up to you, and good luck.
Well, I hope it ain't over yet, but thanks.
Thank you. So Nick, what is actually your problem?
Well, Sajid, I'll tell you what my problem is. So we've been sent this really awesome webcam covers with a Spaces Summit logo on it, but now we can't use it because it breaks your laptop. What do you think of that?
Come on, Nick, that's not it. What is really your problem?
Okay, fair enough. That's not my real problem, but I promise I'll get back to that. So my actual problem is that actually I fractured my motivation. I broke my enthusiasm, and I'll tell you why. So we do have a REST service, which, like any other REST service in the landscape, listens to requests in JSON. On the fly, it fetches categories from an external service, also in JSON. And in our case, we use a library which implements our business logic. So we have a REST interface defining all the endpoints. Let me shrink that a little bit to make the rest fit on the screen. So we have JSON annotated objects representing the request and response payload. We also have some more JSON objects representing the category we fetch from the external source. We have some internal domain objects we use in our service, and we have more domain objects, namely in the library. And yes, that's a lot of dull code to write. So we have 18 endpoints, 18 requests, 18 response objects, 18 internal domain objects, and 18 library domain objects. And there is even more dull code to write because we need to map these JSON objects to our internal domain model, so that's 18 mappers. And we have to do the same to map the internal domain model to the library domain model. Again, 18 mappers. And yes, I'm not sure about you guys, but that definitely fractures my motivation. So that made us believe, can't we actually automate that problem away? Well, luckily, the answer is yes, we can. So Dennis will start showing how to generate your full API and all those request and response objects just out of a few lines of specification. After that, Sajid will show you how to auto-generate your domain objects. Then I'll show you how to avoid writing those tedious mappers. And like any other presentation, we'll end with a conclusion. There's some room for some applause. Not that we'll hear it though, but and if there's some time left, there is still some room for questions, hopefully. But not before I giving you a whirlwind introduction to our problem domain. There's not much you need to know, actually. So the only thing you need to know about is the list page context, which represents a selection a user makes on a list page. So we have a category, in this case, films and series, and the refinements, a list of refinements the user selected on the screen. For instance, year of appearance or spoken language of the movie. So, Dennis, stage is yours. Take it away.
Thank you, Nick, for your introduction. So I will talk a little bit about OpenAPI code generation. But first, I would like to tell you who would have really used a webcam cover. So it's this guy, of course, the Italian singer during the Eurovision Song Festival. But on that note, let's continue. So where are we now? For our project, we had to design 18 endpoints, which means 18 request and response objects, which means a lot of boring, dull work for us. So for our project, we want to use an API first approach. API first, you treat your API as a first class citizen. That means that your API is well documented and versioned in a versioning system, and you first design your API and then start coding. This way you can get feedback on your API from the client, and your API acts like a contract between several parties. The bol.com API Brain Trust guidelines recommends to create a design in a YAML file using the OpenAPI specification. So maybe you heard of OpenAPI, maybe you also heard about Swagger. Well, what is what and why are those terms so interlinked? For that, we need a short history lesson. So in 2009, Tony Tam started or developed the Swagger specification. Swagger specification is a standard way of specifying your RESTful API in a language agnostic way. In 2014, the Swagger specification in intellectual property was bought by the company called Smartware. And in 2016, the Swagger specification was donated by Smartware to the OpenAPI initiative, which made it open source and renamed the Swagger specification to OpenAPI specification. So there are two versions of the OpenAPI specification which you can use, namely version 2 and version 3. OpenAPI version 3 introduced a reorganized document structure so that it's easier to write and reuse API definitions. But be careful, not all tools are ready for version 3, which was in our case, and that's why we stick with version 2. So after some design sessions, we came up with a draft design of our API. The design is a YAML format, and here we have an example of the get list metadata operation. So what kind of things can you specify in your OpenAPI specification? So here we specify the URL path of our operation. You can specify the parameters the client has to send. So in this case, an accept language header, which is required, and you can specify your request payloads the client has to send, and that can be in a separate definition. So this is a simple how we specify the request payload, which is split up in a generic definition. The client has to send a category ID, which is of type string and minimal length 1, and has to send a list of refinements, which is of type array. And with the keywords, all of you can extend your model definitions, and this way you can reuse the definitions. Now we have the design. Then we had an idea, how cool would it be to generate our code directly from it so that our design is in sync with our code and we don't have to write it ourselves. But how are we going to do that? We moved our OpenAPI spec files to a separate module and started experimenting with different Maven plugins. And we found 3 possible candidates. Motormouth, OpenAPI generator, and Swagger CodeGen. So first up is Motormouth. Motormouth is developed and created by bol.com, but unfortunately it's only generated Kotlin code, and we didn't want to introduce Kotlin in our existing project. Now I hear you guys thinking, why not use Kotlin? Kotlin is awesome. Yeah, we also think Kotlin is awesome, but due to time constraints and complexity, we didn't want to introduce it in our project yet. Also, recently I realized that Motormouth generates only client code, and we want to generate server-side code, so we could not have used this plugin. Then we looked at the OpenAPI generator, which is an open source Maven plugin maintained by a community. But due to our setup, we walked into some weird bugs. We split up the OpenAPI design in several files to make it more maintainable using file references, but that gave issues during code generation. A few weeks back, I tried the latest version of the plugin, and the issue seems to be resolved. So we could have used this plugin, but we already switched to another plugin, which is Swagger CodeGen. This is also an open source Maven plugin, and it's maintained by Smartware itself. And this plugin works with our setup with almost no issues. So how would we use this plugin? So here you see the example of our Maven configuration. So as inputs, you give the path to the main Swagger or OpenAPI specification file. You specify to which language and framework you want to generate your code to. In this case, it's a little bit weird because it says language Spring, but that is because Swagger CodeGen supports multiple Spring frameworks like Spring MVC and Spring Cloud. It also supports other frameworks like Jersey, REST Easy, and Retrofit, and different languages than Java like Rust on Go. And we specified that we only want to generate interfaces. Swagger CodeGen can also generate dummy implementations, but that's something we didn't want for our project. So now when you type in Maven, compile, and enter, all this code is nicely generated by the Swagger CodeGen plugin, which is awesome. You don't have to write it yourself manually. So let's zoom in on the code generated by Swagger CodeGen. So remember, this was our design for the get list metadata operation. And the plugin generates an interface method for it, with here the specified URL path, the accept language request header, and the request payload we specified. And also all the correct Swagger and Spring annotations are generated by the Swagger CodeGen plugin. So this was the payload we designed. And Swagger CodeGen generates the list-based context as a POJO. It has all the correct fields, and it generates all the getters and setters for us. All the generated files are put in the target folder and bought and packaged in a jar file. Now we have a separate project with all our generated code, which we can use as a dependency in our service. In our service project, we only had to extend the generated interface, and with the help of Maven and Actual, and with the help with Actual and Spring Magic, our design is also visible as a Swagger UI page on our internal endpoint. If you need to make a change in our API, we can easily update the design in YAML files. And then thanks to the Maven plugin, the changes are automatically propagated to our service. So in the end, we are happy with our setup. Our clients are happy with a well-designed API. So it was time to part. So to wrap things up, we've seen we designed 18 endpoints, designed 18 request response objects, and we didn't have to write it ourselves. Cool. But now we have to create our models for the internal logic. So how are we going to do that? For that, I will give the word to Sajid.
Yes, thank you, Dennis. So now I will be talking about how we generated our immutable objects using Immutables framework. Before I start, I want to address the real reason why we weren't allowed to use webcam covers, or so I think. I think it's because now Yuri can't see if people are actually working from home. But Nick will tell you more about this later. Okay, so what's up next? My part of the presentation will cover how we generated all our domain objects with a service and the domain objects within a library using the Immutables framework. But hold on, some of you might be wondering, why would you need to separate the internal and external models? So why are we not using the API models internally within our service? Well, I can give you a few reasons why. Firstly, it only makes sense to keep the models the same if they are exactly the same, and they will also stay the same for the future. So what if we want to add a field only used by the business logic? Now this field will also be exposed in the API model, and this is a potentially breaking change. So let me quickly illustrate this with an example. So in this case, we have the same model, that is the list page context, being used in the API as a request model and also internally within the service. So imagine that we need to add an additional field to the internal model for which we need some business logic. So we add this field. And what happens now is that this change also gets propagated to the API model. And this will break the API for our clients because now the request payload needs an additional field. So now that we decided we needed to create separate internal models, we actually had to create around 36 of them, and laziness got the better of us. So we opted to instead generate all our models. So what are the advantages of generating domain objects? Firstly, it saves us a lot of time since all the necessary functions such as getters, setters, and builder methods are automatically generated. Secondly, it results in cleaner code since the class interface you design is not bloated with helper functions, and it is easy to see in a quick glance what fields are provided by this class. Thirdly, it is easier to maintain. In case you want to change any variable name, for example, the corresponding functions which use this variable are automatically updated. And lastly, you can make use of annotations to automatically generate things such as null checks, to generate no arguments constructor, and many more. So there are three popular frameworks out there for generating classes. And I guess the most popular one is Lombok. And then you have Google Autovalue. And then you have Immutables.org. And for our project, we chose Immutables, not because we thought it was the best option, but because it was used in one of our existing projects. It's not that we were lazy, it's just that we didn't care. But hey, we got lucky because we actually did some research recently, and it looks like Immutables is the best option out of the three. But don't take my word for it, let me show you why. So now let's compare the three frameworks in their ability to generate classes, in their ability to facilitate creating and updating objects, in their ability to be fully immutable, and other out-of-the-box features they provide. So let's start with comparing how they generate classes. So in Lombok, classes are actually generated by modifying the bytecode of the original class. And because of this, you cannot view the generated Java class easily. And this might make it harder for you to troubleshoot errors. Because Lombok modifies the original class, it can also be difficult to integrate within IDEs and to generate Java docs. In the case of Autovalue and Immutables, however, the generated class is separate from the original class. It simply extends it. And this avoids all the problems we just mentioned. And the generated class is added to a target directory and has a different class name to avoid any confusion. So for this case, we can see a clear winner, and that is Autovalue and Immutables. So now let's compare how these frameworks handle creating objects using the builder pattern, and also if they allow updating these objects. So for Lombok, you need to manually specify the builder annotation to generate the builder methods. Lombok provides methods to update an object, and it does that by creating a clone of an instance with an updated field. This is called a wither method. So in the case of Autovalue, you manually need to create the builder methods, which is really cumbersome. For Immutables, the builder methods are automatically generated without needing an annotation. It also provides a wither method compared to Lombok, like Lombok. On top of that, it also allows you to generate a modifiable version of a class, which can then be converted to an immutable instance. Here, Immutables is again the winner. So now let's take a closer look at two ways you can generate builder methods in the Immutables framework. So sometimes you want to enforce that all the required fields for a class are set during the instantiation. So for the default builder method that gets generated, it's the normal builder. And in this case, you can build an object by setting fields in any order you wish. And here the builder cannot enforce that all the fields are set. And missing fields, if any, are only found during runtime, which is really bad. Whereas in the case of stage builders, you can only build an object by setting fields in a strictly enforced order. This actually enforces that all the required fields are set, and you cannot call the build method otherwise. And as a result, the biggest advantage is that missing fields are already found found during compile time, which allows you to catch errors much sooner. And you can achieve this in the Immutables framework by using the stage builder equals true annotation. However, there's a small caveat. It's that stage builders do not work well with MapStruct, but Nick will tell more about it later. So let's understand this better with an example. So here, there are three ways an identity refinement object can be built. And for this object, the ID field is mandatory. So in a normal builder, you can call all the builder methods in any arbitrary order. So all the three lines will compile. However, the third line will fail because during runtime, it will find out that the required field ID is not set. In the case of a stage builder, however, you can only call builder methods in a strictly enforced order. So only the first line will compile. The second line will not compile because the order in which the fields are set is not correct. And the third line will clearly fail because the required field ID is not set. So yeah, this proves that one does not simply forget setting a mandatory field when using stage builders. So let's dive a bit deeper into generating objects and discuss the advantages of generating immutable objects. So what is an immutable object? An object is considered immutable if it cannot change its state once it's created. The first advantage is that it has a consistent state, and this prevents accidental changes from being done and also makes it easier to test. Secondly, it enforces thread safety, and the objects can be shared safely across threads without needing any sort of synchronization. Thirdly, immutable objects can be cached since two immutable objects with the same values are completely equal, and it results in it being safe to reuse cached values. This in turn reduces the memory footprint and the garbage collection cost. And lastly, there is better encapsulation since the object can be passed around with reference without worrying about the underlying values mutating. Thankfully, all the three frameworks support generating immutable objects. So before we compare the three frameworks on how they handle immutability, let's briefly discuss the difference between a shallow copy and a deep copy. So when creating copies of arrays or objects, one can create a shallow copy or a deep copy. A shallow copy uses pointer references of the original values. So let's look at an example. Let's assume that we have an array called values. Now, if we shallow copy this to an array called data, the values are only copied by reference. A deep copy, however, actually recursively copies values of the original. So if we deep copy values to a data array, a new array is created in memory, and then the values are copied over. So now let's see how Lombok and Autovalue copy values when building an object. So in this case, we create an array list and we add a first value to it. Now let's assume that test model is a model generated with either Lombok or Autovalue. So we build this object and we assign this mutable list we created to the class field called test list. Now, if we add a second value to the original list we created, and we assert that the number of elements in this class is unchanged, that is, the number of elements in the class list only contains one value, what do we expect? It fails, since Lombok and Autovalue only copy values in a shallow way while building the object. So this proves that even if the object itself is immutable, it can still be modified from another reference, which is dangerous. So if you could generate fully immutable code, that would be great. So now if you run the exact same test for a model generated using immutables, we can actually see that the test succeeds because immutables actually deep copies the underlying values when building the object. So we can say that immutables is safer compared to Lombok and Autovalue since the object is completely immutable. So now that we've declared that immutables is the winner in every aspect, let's take a look at how much code immutables actually generates. So this is the piece of code you need to manually type in, and then you need to make use of the value.immutable annotation. So here we define three class fields, one of them being optional. So when you compile this, you actually get this piece of code. So as you can see, around 600 lines of code are being generated, and Immutable does all the heavy lifting for us and generates quite a lot of useful helper methods. Now let's take a closer look at the generated class. Here, the generated class implements the original class interface we defined. And all the class fields are declared as final so that it cannot change. And you can also see that the optional field we defined is marked as nullable here. Several getter functions are also generated with support for Java optionals out of the box. A wither function also gets generated, which allows you to create a clone of an instance with an updated value. A copy of function is also created, which allows you to create an exact copy of the instance in a very easy fashion. And several builder methods are generated. And here you can see that Immutables has support for adding a list of values using a var args parameter. So in this case, you don't need to wrap your values in a list when you want to add a list of values. So yeah, I'm sure some of you might be wondering, why not use Kotlin since it has data classes? Well, like Dennis mentioned earlier, we of course thought about that, and we do love Kotlin, but due to time constraints, we couldn't migrate our code base. But for those of you out there who prefer Java, using Immutables is the way to go. So now we showed you how we efficiently generated our internal domain objects and our library objects using Immutables. Next up, Nick will tell you more about how we can map the API models Dennis created to the internal models I created using MapStruct. So take it away, Nick.
Yes, let's do just that. But first, I think I might have solved our little webcam cover problem. I found a way to still use it. You only need a pair of scissors, a pair of sunglasses, a paper brown bag, and of course your really cool Spaces Summit webcam cover. And ta-da! Yeah, that's me, fully incognito. Okay, so on to more serious business. So finally, I'll show you how to avoid writing those tedious mappers, mapping one object to another field by field. And we had to do that 36 times in our code base. So we found that much of our models actually are like identical twins. So if you look at the source and the target, you'll see that the source and target have the same amount of fields, same name, and are of the same type. And that made us wonder, yes, can't we automate the problem away? And again, the answer is yes, we sure can. Because there are actually a lot of mapping frameworks out there which can do just that, each one relieving you from the tedious task of writing this boring mapping code, because that's what it is, boring. So there's Dozer, there's JMapper, there's Orca, there's MapStruct, and there's Model Mapper. Now, the question is, which one of those is the best framework? Which one should you pick for your particular project? Well, it kind of depends on your requirements. But for us, yeah, we did the research first, unlike the Immutables. And what for us matters is the framework performance, because we have a REST service, which requires low latency. So performance is key for us. Community involvement, and ease of use. So let's start with performance. So luckily, we didn't have to write our own benchmark. That has already been done for us, and we just needed to consult this excellent blog post. So yeah, let the metric speak for himself, I would say. If we look at the throughput, the number of operations per millisecond the framework can do, we see that JMapper and MapStruct definitely outperform the other three. And the same kind of goes for the average running time. Also there, MapStruct and JMapper clearly win from the rest. They're much faster. So yes, ladies and gentlemen, we have a tie. We have MapStruct and JMapper still in the race. Too bad for Dozer, because I really think that's a cool name. So next, let's have a look at the community involvement. So if we look at the GitHub activity of MapStruct, we'll see that the project started somewhere 2013. We have a steady line of commits from that point on till today. If, however, we look at JMapper, we see that the project started somewhere 2015, and after 2017, we see a weird blue line. So in case you wonder what that weird blue line is there, well, that's actually the sound the cricket makes, because nothing happened there. So this project is like nearly dead. So yes, we have a winner. MapStruct it is. Oh, wait a minute. What about ease of use? I mean, if it's yeah, not usable, then yeah, why even bother with it? Why not write those mappers yourself? And ease of use, of course, is very subjective, but we tried by just starting to write our own mappers for some real world objects in a real project. And we did do our evaluation after that. So in particular, we tried mapping multiple sources to one target. We tried mapping optional fields, because we have quite a few of those in our project. We tried mapping object hierarchies, because actually the refinements come in different flavors, as we shall see later on. Like Sajid already indicated, we are using builders, so MapStruct should also be able to deal with those. But let's start with a simple case, the case of the identical twins, where the models are actually quite similar. That also includes lists. So here we have a list of translations with a nested object. So the translation object is just a nested object, which also has similar fields. It are identical twins. So in this case, we're mapping the domain objects in the surface to a library objects. So to go for this case, we just need to define one interface, a mapper, annotate it with a mapper annotation, and tell MapStruct that we're looking for a method which can map our internal domain model to the library category model. Compile, and there you go, a fully generated mapper. Look at all those lines of code we didn't have to write ourselves. Isn't that great? So let's have a closer look. So what MapStruct did do for us, it did implement our interface. It annotated the class with a Spring component, that's configurable. But for us, we use Spring, so that's great. It did implement the mapping method we requested, the one mapping an internal category to its library counterpart. It did generate a method for dealing with the list of translations, and it also defined a method to map those nested translation objects that go in the list. So let's have a closer look at the to-lib mapping method, the one we requested. So if we look at that, we'll see that MapStruct starts with doing a null check. We'll see that that one's not ideal later on. It instantiates a builder, so it does play well with builders. It uses the builder to set each field, copying from the source to the target model. It does use the helper method we've just seen for dealing with the list of translation objects. And ultimately, it returns a build category object. So this is basically the code you probably would have written yourself. So key points. MapStruct generated 50+ lines of human readable code. It annotated the mapper with a Spring component, and it supports builders out of the box. Okay. Fair enough. I kind of lied there. Like Sajid already said, it doesn't play well with stage builders, or actually, it doesn't play at all with stage builders. It simply does not work. So we had to drop our stage builders. Unlucky, but that's the way it is. And we only needed one interface with one method, mainly because the objects are like identical twins. But what if they're not? What if some fields are actually different? Well, would this still be a simple case? What if in the source, the category ID is just named ID, and in the target, it's named differently, category ID, for example? Well, in that case, we only need to tell MapStruct about it by defining a mapping annotation, stating that the ID from the source actually maps onto the category ID in the target. And from there on, everything works just fine. It's good to realize, though, that if you have a lot of differences, then, well, MapStruct might not be the tool you need, because then you still end up writing all those mappings. Right, so having that said, let's have a look at a more difficult case, mapping two sources to one target. So in this case, we have a list page context, the internal domain model, which has a list of refinements, which we need to map onto the library counterpart, and the category comes from a separate object, the external service we fetched it from. So in that case, we only have to specify all the sources in our mapping method, starting with the context where the refinements are defined, and then we have to provide it the category. And Also, this just works out of the box. That's great. Now let's have a look at mapping optional fields. And this is the case where we kind of run out of luck. So what if the category is actually an optional field? So would this mapper still work in case the category can be null? And in that case, we want to have an empty optional. Well, like I said, yes, we ran out of luck here because MapStruct doesn't know how to do it. However, on the bright side, it does give us a quite descriptive error message stating what it cannot do, where the problem is, and it also gives us a hint on how to fix it on the method we have to implement ourselves. So remember that category mapper? So the problem is that we did tell, or actually MapStruct does know how to map an internal category to a library category, but it just does not know how to make an optional out of that. So we have to help MapStruct a little bit here by telling it how to map something that's not an optional, that's nullable, to an optional. And in this case, it already suffices to write your own custom mapping method, which can map any arbitrary nullable object to an optional. And here you see the example. Just take optional of nullable and you're done. And that works, because as we see, MapStruct first uses the mapping method it generated itself to map this domain object to the library counterpart. And after that, it uses our custom map to optional method to wrap it into an optional. So everything is fine. Well, is it? What's that null check doing there? What if the category is actually null? Well, it will never be set, right? Well, that's just great, MapStruct. So Dennis, what's your opinion on this? Yeah, I agree. I'm also speechless. Don't know what to say. Okay, let's see how we can fix it, because we did fix it. So the full solution, a full explanation of the solution is beyond the scope of this presentation. I did put the solution on the slides just for future reference. But in a nutshell, we had to implement again our custom method, a custom mapping method. So we needed to help MapStruct a little bit on how it could map this particular case. And we had to use an expression to overrule the auto-generated mapping. And that's something to remember, folks, because an expression is really your friend. It's your last resort. In any case, MapStruct gets lost and don't know how to map something. And just, well, to prove, it does work. So there's no null check here anymore, and it does use our own mapping method. And yeah, I guess those are just the 15 minutes of actual work we have to do. Well, in reality, it was much more work, I can say. MapStruct really gave us a hard time here, but yeah, we fixed it. It's possible to do it. Okay, finally, let's have a look at mapping object hierarchies, because like I said, refinements actually come in different flavors. A refinement can actually be an identity refinement, a specific one value thing the user has selected, for example, the color red, but it can also be a range, for example, price, 10 to 100 euros. So would it be enough to just ask MapStruct for one method for the base class, like this? Well, unfortunately, no, MapStruct cannot deal with that. So let's start with what MapStruct can do. Let's try to fix it. So what MapStruct can do for us, it can generate all the mapping methods for us for the base classes, for the subclasses. So we specify mappers for each subclass. So we don't have to write them ourselves. And once MapStruct uses that generated, MapStruct generates those methods for us, those mapping methods. We have to define the case for the base class ourselves. Which means that we have to check which particular type it is, doing an instance of check. And after that, we can call the MapStruct method, the converting method, MapStruct generated for us. So yeah, just in case you're not impressed by those instance of checks, well, that's good because neither are we. well, we've written a couple of blogs on MapStruct, and you can find them on Tech Lab. So there you can find some more inspiration and some more solutions on how to deal with hierarchies of objects and how to deal with optional fields and all the problems you will run into and how to fix them, of course. So finally, I've shown you how to avoid writing those tedious mappers. Bang, all generated. So Sajid, stage is yours.
Yeah, thank you, Nick. So let's conclude this speech. So firstly, why should you use OpenAPI? Well, it makes it easier for you to create an API design. This API design is well documented and shareable at the same time. The API design and code are in sync with the help of generators. And these generators can generate code in a lot of different languages and frameworks. Why should you use immutables? Well, it saves you a lot of time by auto-generating cumbersome code. These generated models are immutable, so it enforces thread safety, and it has a lot of powerful annotations which provide functionality out of the box. And lastly, why MapStruct? Well, because it alleviates you from writing tedious mappers that are as fast as the code you would have written yourself. However, there is no out-of-the-box support for mapping optionals and class hierarchies, and it's also not possible at all to work with stage builders. So we hope we demonstrated why laziness is a good thing. So please do tell my manager I generate all my code, because now I can spend my energy on more complex challenges for the things that really matter. Thank you for listening, and do you have any questions?
All right, thank you, Dennis, Sajid, and Nick, for your presentation. I'm looking right now live at Mentimeter to see any incoming questions. And this is the first today I don't see any incoming questions on Mentimeter. What I did notice is a great conversation taking place at Google Chat. So do you guys have access to the Google thread of the Spaces Summit? Can you locate your own thread? Maybe there are some questions you can see. All right, I can still see you guys. Still great presentation. All right. All right. So no questions. We do have a delay, so sometimes a question can come in, like, let's say 30 seconds or 40 seconds later. Or the story was just amazingly clear, right? It could also be the case.
Well, let's hope that's the case.
I think that's the case. That should be the case, right? So do you see anything interesting in the Google thread, guys?
Actually, I closed Google Chat, so.
No, you go Google. Yeah, that's another thing you might want to do when you are presenting, of course. I think it was more of a discussion than a really question and answering going on there. Still nothing on Mentimeter for my side. So what I would suggest is if you guys can go over to Google Chat, you can have the rest of the day to join the conversation on your great talk, answer any questions that will still come up. And thank you guys for joining us at Spaces Summit. All right.
For listening. Thanks for having us.
All right.
And good luck with the rest. Enjoy, guys. Bye.
Bye-bye.
Bye.
So that were Dennis, Sajid, and Nick about how to generate a code and how you should tell your manager that you're generating your code, of course.